Hello there and welcome back to this video series on programming for problem solving using C language. After watching this video, you'll be able to use this atoi and atf functions. Prerequisites for this video are video 8, which illustrates about IEEE 754 standard. We may need it somewhere towards the end of this video. And as obvious, videos 45 and 46, which describe strings in brief. With that, we'll try to go in and see what this atoi and atf functions are. Okay, this function atoi converts a string of numbers into an integer. Similarly, this atf converts a string to a floating point number. You note that the reverse of the inverses of these functions I to A and F to A are non-standard and may not be available in some compilers. You need to be careful about that. Okay, atoi is short name for ASCII to integer. It will take an ASCII character series and convert it into an integer. We may think that we want to shorten it as ASCII to int, but in the grand old days only 8 characters were allowed. That is the reason why A to I came in. A to F is ASCII to float conversion. We'll try to see this with an example. You need to include this stdlib to access all these data conversion functions. You have a string S which contains 1, 2, 4, 5, 4 ASCII characters. In fact, it contains 5 ASCII characters because that \0 is at the end. Similarly, in string T, you have 1267.323. These are the ASCII characters which are stored. Note that 1245 is different from the characters 1, 2, 4, 5 in series. Okay. What we are trying to do is we take this ASCII stream of characters 1, 2, 4, 5 and convert it to an integer. Similarly, this ASCII sequence 1267.323 will take it and convert it to a floating point number. A to I converts it to integer. A to F converts it to floating point number. With that, we will try to compile this program and execute it and see. We compile it with gcc command and we execute it with a.out. Carefully notice that integer came out exactly as it is, unscaped, 1, 2, 4, 5. But the floating point number came out to be slightly different. It didn't come out to be 0.323. Okay, it came out to be 0.32298, which is kind of surprising, but if you carefully follow through the IEEE 754 conversion, there is an approximation involved. That approximation is what caused this. Okay, you need to carefully note and understand this perhaps. I think that's all we have for now. And there are a few other data conversion functions, and you are encouraged to look them up in the textbook or on the web resources. That's all for now. Have a great day.